Hello, welcome class. So what I wanted to do is create shorter, more condensed videos for solving rational equations. I'm going to work on that in this particular video, and then I'll make another one related to variation. So let's take a look and kind of recap what we should have been discussing last week on rational equations, and hopefully this kind of helps to clear up any questions you might have on the homework and get you set up for success. So let's take a look at our first example. Problem number 1, we have r minus 4 over 5r is equal to 1 over 5r plus 1. The very first thing we're going to consider is we need to make sure that we are deciding what those excluded values are, right? We're going to focus on factoring. In this case, we don't have any polynomials that we actually need to factor. 5r is a 5r. We're not going to actually factor that. So then we consider what the excluded values are. So we know that we have an excluded value when our denominator would be equal to 0. The only way for our denominator to be equal to 0 in this case is if r itself is 0. So think of the idea of taking the denominator, setting it equal to 0, and then solving. So if we solved for r, we'd see that r cannot be 0. If the value of r ends up being 0, then it's actually not a solution, and we would not have a solution to actually write down for this particular rational equation. So let's keep this in mind, that r cannot be equal to 0, and let's move through the problem and see what happens. So notice here that we have 3 terms, and we also notice that the LCD in this case would have to be 5r. So we're going to take each term and write them in parentheses, and we are going to use a strategy we've used so many times before, and we are going to multiply each term by 5r. Notice when I multiply each term by 5r, I can actually go ahead and cancel out those denominators. So remember, we're dividing out the common factors. So in this case, 5r divided by 5r, same thing here. And we notice we no longer have any fractions. So what we're left with is 1 times r minus 4, or simply r minus 4 is equal to, notice our 5r is canceled, so 1 times 1, which is just 1. And then plus 1 times 5r, which is 5r. In this case, I'm going to go ahead and start solving. I'm going to bring the smaller value of r to the right-hand side of the equation. And notice here, r minus r, they're opposite, so they cancel out. I'm going to bring down my -4, bring down my equals, bring down my 1, and then 5r minus r is a positive 4r. I'm now going to subtract 1 from both sides. Notice that that'll leave me with a -5 is equal to, our terms cancel, is equal to 4r. We divide by 4 on both sides, and we see that the value of r will be -5/4. So you can represent your answer as a value within a set. So r is equal to -5/4. Let's take a look at another problem. For our second problem, we have r plus 5 over r squared minus 2r minus 1 is equal to 1 over r squared minus 2r. We notice in the denominators that we can definitely factor. And if we think about our flow chart and the process of factoring, the first thing we're going to look for is a GCF and a leading negative. Notice in our polynomials, we certainly do not have a leading negative, but we definitely have a GCF. So we're going to factor the denominators first. That leaves us with r plus 5 over, notice we have a GCF of r, so we're going to factor that out. And if I factor out an r from both terms, that leaves me with r minus 2. Then I have minus 1 is equal to, we're going to do the same thing here for our denominator r squared minus 2r. We notice that it ends up factoring into the same thing. Now that I have my denominators factored, I can consider now where my excluded values are. So notice here we would set each factor containing a variable equal to 0. So essentially we have r is equal to 0 and r minus 2 is equal to 0. Because remember, we're trying to find where those pitfalls are. We're trying to figure out what are the values that will cause this to be undefined. Any fraction divided by 0 is undefined. So we go and we solve. We see that if r is 0, that would result in an undefined equation, undefined problem. We also notice that when we solve for r in our second equation, that r could also not be 2. If the value of r is 2, then that would result in an undefined solution as well. So we keep this in mind and we say that if we solve and we get that r is 0, we have to throw it away. If we solve and we get that r is 2, we'd have to throw it away because that is not a valid solution. So keeping that in mind, let's go through the process of solving this rational equation. We state again what our LCD is. In this case, we know that in order to make our denominators match, they should all be r times r minus 2. So we're going to take each term, wrap it in parentheses, and we're going to multiply by that LCD, r times r minus 2. Do that again for our second term, and do that once more for our last term. Notice in our first term, we can cancel, so r's cancel and the r minus 2 cancels out. Remember, we're dividing out common factors. So that leaves us with 1 times r plus 5, or simply r plus 5. Next, we have negative 1 times r minus 2. I would actually prefer if you write this out before we distribute. So I would suggest negative 1 times r is simply negative r. But don't forget that that's being multiplied by r minus 2. I do this because I want to make sure that we do not drop this negative sign. So we simply multiply the coefficients and we wait to distribute. So we'll do that in a moment. For our last term, the r's divide out as well, and so do the r minus 2 factors. And that leaves us with just a 1. Now we're going to go ahead and distribute and combine like terms. So we have r plus 5, we have negative r distributed, that becomes negative r squared. That's an interesting turnout. Negative r times a negative 2 is a positive 2r, and that's equal to 1. Notice here that my term with the highest degree happens to be negative, and that's not a big deal. Really, that's not an issue. We're just going to keep that in mind as we go through this problem. I am going to go ahead and combine like terms. We have r and 2r, and we have our positive 5 and our positive 1, although 1 is obviously on the opposite side. So let's work through this. We have a negative r squared, r plus 2r, that's 3r. We have a positive 5, and that's equal to 1. Now, considering that we recognize that when we have a polynomial equation, we can attempt to factor and solve. There are other techniques that we'll learn, but right now we're focused on the techniques that we have, which are to factor and then solve. So in order to do that, I need to make sure that I set my equation equal to 0. I'm going to write this in standard form. So we have negative r squared plus 3r plus 4 is equal to 0. Now, as we recall, the very first step of factoring is GCF, or leading negative. So in this case, I have a leading negative 1. So I'm going to go ahead and factor that out. When I do that, I'm left with r squared minus 3r minus 4 is equal to 0. When we look inside the parentheses, we have a trinomial. And specifically, this trinomial has leading coefficient equal to 1. So because I have a trinomial with leading coefficient equal to 1, the factoring technique that I'm going to use is trial and error. This is something that we've talked about many times, and I find that we actually enjoy trial and error quite a bit. So we're going to start by multiplying a times c, 1 times negative 4, which is negative 4. And we want to find factors of negative 4 that combine to give us a negative 3. You'll notice that's going to be negative 4 times 1. So negative 4 times 1 gives us negative 4. Negative 4 plus 1 is going to give us the negative 3. So when we go ahead and write our factored form, we notice that to get an r squared, we break that down into r times r. And then our factors will be inputted in the parentheses. So we have a negative 4 and a positive 1. I'm going to go ahead and write my factored form here. So we have negative 1 times r minus 4 times r plus 1, and that's equal to 0. But as we learned from a previous instruction, we need to take each factor containing a variable, set it equal to 0, and solve. So I'm going to note here that we have r minus 4 is equal to 0, and then r plus 1 is equal to 0. Let's go ahead and solve. We find that r is equal to 4, and we also find that r is equal to negative 1. Notice from the very beginning, our excluded values were 0 and 2, and I can write that above here, excluded values. That way, we can keep track of what was going on here. So these are my excluded values. But luckily for us, we got a 4 and a negative 1 as our solutions, and that is totally okay. So we can go ahead and express our solution in set notation. So we see here that r is equal to, like I said, negative 1 and 4. Let's take a look at one more. All right, here is our last problem for this very short video. We have m over m minus 1 minus 1 over m minus 2 is equal to 2m minus 5 all over m squared minus 3m plus 2. Okay, let's go through the motions. The first thing we're going to do is we are going to factor our denominator. So we have m over m minus 1, this one's totally fine, minus 1 over m minus 2. And then over here we have m squared minus 3m plus 2. So we need to work on factoring this trinomial whose leading coefficient is 1. Recall that that would represent our trial and error. So we have 2m minus 5. I need to factor this trinomial such that I find factors of positive 2 that combine to give me a negative 3. So first off, m squared breaks down into m, and factors of positive 2 that combine to give me a negative 3. Think of it this way. I know that 2 times 1 gives me 2, but I need a negative 3, so that implies that both factors must be negative. Negative 2 times a negative 1 is a positive 2. Negative 2 minus 1 is a negative 3. Let's go ahead and write minus 2 and then minus 1 in the parentheses. Okay, first I'm going to look for my excluded values. So let's go ahead and write this down. Excluded values. So we see here we have an m minus 1, an m minus 2, and a combination of the two. So we're going to set each of these equal to 0, and we're going to solve. So in this case, we see that m is equal to 1 and m is equal to 2. So if we solve and our solution is either 1 or 2, we will have to throw that solution away because it would be an extraneous solution. It would present an undefined answer. So we have to be very careful with that. But now that we have that identified, we're going to go ahead and use our strategies. So we are going to take each term and again multiply by the LCD. Notice that this fraction would just need an m minus 2, right, to make the denominator the same. This one would need an m minus 1 to make the denominator the same, and this already has it. That implies that the LCD must be a combination of the two factors. So we're going to multiply each term by m minus 2 and m minus 1. So again, even this last one, I know it gets a little bit cramped, but I promise it's helpful to write this out and actually show what's happening. So in our first term, notice that our factors m minus 1 will divide out, and I'm left with m times m minus 2. I like to rewrite it first before distributing. I promise it will help with any signs, and it'll make sure that you're keeping track of all of your terms. We're then going to divide out an m minus 2. That will leave me with negative 1 times m minus 1. Again, not distributing until I am ready. Is equal to, notice our m minus 2 factors will divide out and the m minus 1 factors will divide out as well. And that leaves me with simply 2m minus 5. Now I'm ready to distribute and see what happens. So distributing our m leaves us with m squared minus 2m. Distributing negative 1 leaves us with negative 1m plus 1. And of course, bring down the equals 2m minus 5. Let's combine like terms. And then, of course, you're starting to notice that because we have degree 2 or higher, we're thinking polynomial equation, set equal to 0, factor, and solve. It's going to be the same story again and again until we learn more sophisticated techniques. Negative 2m minus 1m is negative 3m plus 1. We are now going to bring over our 2m. Remember, we're going to use opposite operations for each term individually. We're going to subtract the 2m, and we're going to add the 5. This way, we can set our polynomial equal to 0. So let's go ahead and combine like terms. We have m squared, negative 3m minus 2m, negative 5m, plus 1 plus 5, that's plus 6. Again, we lucked out. We have a trinomial whose leading coefficient is 1. So we're going to use trial and error once more. So we want to find, we'll drop down our m's, right? M squared breaks down to m and m. We want to find factors of 6 that combine to give us a negative 5. So think factors of AC that combine to give us B. And we're just using trial and error here. So when we think of factors of 6 that combine to give us negative 5, well, that's got to be 6 and 1 or 1 and 6. And we have to be careful with our signs. Or is it? So let's test this out. We have to be careful with our signs. We need a positive 6, but a negative 5. If I assign a negative to each of these, that actually fails. Negative 1 times negative 6 is a positive 6, but negative 1 minus 6 is actually negative 7. So this pair of factors does not work. But let's try 2 and 3. We'll go ahead and make both of these negatives. We see that negative 2 and negative 3 multiplied together gives us a positive 6, and voila. These two factors do work and combine to give you a negative 5. So be very careful. Don't take anything for granted. Test each of your factor pairs. We're going to bring over the negative 2. We're going to bring over the negative 3. And of course, equal to 0. We're going to set each factor containing a variable equal to 0 and solve. So we have m minus 2 equals 0 and m minus 3 equals 0. When we go ahead and solve, I add 2. So we see that m is equal to 2. I'm going to add 3. We see that m is equal to 3. But then I check back in with my excluded values and I notice, hold on, one of my excluded values was that m can't be a 2. But I solved and I found that m was 2. So this is called an extraneous solution. So it's an extra solution that will not work for this particular equation, because if we plugged in 2 into our denominator, notice here, it would result in 2 minus 2, which is 0, and 1 divided by 0 is undefined. So it does not work as a solution. So we would cross that off. 3 is totally okay. There are no exclusions for 3. So we'd say that our solution in this case is m is equal to 3. So I'm going to write over here that this solution was extraneous. And that is why we just started. So this is a perfect example of what it looks like if you did have an excluded value as a solution. You would recognize, okay, this is extraneous, so it's no longer valid. Anyways, I hope that this video helps and that you're able to do your homework no problem. Good luck. Bye.